Hi everyone, welcome to MRU E-Learning powered by Malla Reddy University. I'm Alluri Shruti, Assistant Professor from IT Department. Today I'm going to say RSA Algorithm in Cryptography, where RSA Algorithm is the symmetric or a public key cryptography algorithms, which it works on the two different keys, whereas public key and the private key. This algorithm is named after the Rivest and Samir and Alman, this algorithm was published in 1977. The example of symmetric cryptography is if a person sends a message securely to the person B, a person encrypts the message using the person B's public key, where person B is public key. The person B decrypts the message using their private keys to get the original message. Whereas RSA algorithm is based on the factorization of large numbers and modular arithmetic for encryption and decryption the data. It consists of three stages, where key generation and encryption and decryption. In key generation, it creates the public key and private key, where encryption here sender encrypts the data using the public key to get the ciphertext, whereas decryption decrypt the ciphertext using the private keys to get the original data. Then the key generation choose two prime numbers, says P and Q. These are the prime numbers should kept secret, where N is the product, where this is the private key as well as a public key. N equal to P into Q. Where now we are going to calculate the totant function, where pi of N equal to pi of P minus 1 into Q minus 1. Here we'll get an totant product. Encryption exponent equal to E. E is 1 less than or equal to E and less than or equal of pi of N. And GCD here, GCD of E and pi of N should be equal to 1. E should be the co-prime number with pi of N. Whereas the decryption product of D into E is concurrent to 1 of mode pi of N is known as to get the decryption value. And finally, the public key equal to N comma E and the private key are N comma D. Encryption of the message first convert into the numerical representation using the AICI, where encoding the schemes using the public keys N comma E to encrypt the message to get the ciphertext using the formula ciphertext equal to message mod E mod of N. C is the ciphertext here, M is the message, and E and the N are the parts of public key. Whereas decryption, M, here we have to get the original message. M equal to C of D mod of N. Here C is the ciphertext and D comma N are the private keys. The example of RSA algorithm, the sender sends the message and the receiver receives the message which is in the secret one. For example, P equal to 7 and the Q equal to 19. The product of N is 133. Then now we have to find the totant value. P minus 1 means 6 and Q minus 1 equal to 18. 6 into 18 equal to 108. T equal to 108. and N equal to 103 and the Q equal to 108 here. Now, select the public key of E. Here, we have the three conditions here. It must be a prime number. It must be a less than the totant, means it should be less than the 108, and must not be a factorial of totant. Okay? Then we'll go for decryption, where here the product of D and E divided by the T it must be equal to 1. Encryption and the decryption. Now here E equal to, we'll go with 29. It must be a prime number and it is less than 108 and it not be the factorial of the totant. Then D will take it as a 41. It must be the remainder of 1. So 29 into 41 will get 1089. Then mode of 108. Here T equal to totant equal to 108 is equal to 1. Here ciphertext of message will take off message of 60. 60 into E equal to 29, mode of 29 of mode of 133. Right? We'll get an ciphertext of 89. Okay? Here 89 of D value is 41, mode of 133. We have to get the original message. The original message is 60. Here we'll get the 60 here. Then applications of RSA algorithm, we'll use some applications of the RSA algorithms and sending the information safely and the digital signatures and secure the website, whereas the safe communications and login with the remote computers. Thank you all.